Hey everybody. I'm going to be presenting ops for devs. Before I get started, I'd like to say, thanks for showing up for my talk. I appreciate you all being here. Yeah. I guess I should tell you who I am. My name is, again, Adam Ulvi. I work for a company here in town called Z Health. We do computer stuff, much like yourselves. I also help organize or co-organize the meetup here in town. So I recognize some of you from the events, and those of you who live here that haven't been to the PDX Node meetup, come on out, it's awesome. We get between 30 and 40 people, and it's great, it's a lot of fun. I also am pleased to share that I am the infrastructure lead for the jQuery Foundation. So this is a really fun volunteer position for me because it allows me to do infrastructure and ops work, something that's not generally a full-time component of my job at this season of my life, as people sometimes say. But I've always enjoyed systems work, and early on in my career I cut my teeth doing it. So I want to stay current with it, and it's an important skill that I believe makes me a more well-rounded developer. And I also find the space really interesting, and so I'd like to share with you some of my personal interests and around infrastructure and operations and how that relates to the work that we all generally do pretty regularly. And I'd like to do that with a practical example. So I think we're going to go through the entire process of registering a domain, creating a virtual machine, loading a Node application onto it, and then seeing if we can actually hit the thing. Okay? All right, great. So this is my setup, right? You have to have a problem and then frame the problem. Here's a problem. You develop the world's greatest app, late at night in your garage. This is me anyway. Late at night in my garage, I've been typing away, and I finally finished the world's greatest app. And it works great. It's got full test coverage. It's got, the whole thing's amazing. I can't wait to release it on the world. But the problem is, it only exists and only runs on my laptop. So how do I get it to the public? How do I get it so you all can touch it, right? That's the problem. People on the internet can't fire up their favorite browser and gaze upon my brilliant application. This will not stand. So we have a number of different ways we can solve this problem. And my personal favorite is to self-host, right? Now you could go a number of different routes. There's a lot of talk about serverless infrastructure, and we're all working on ways to remove complexity from our architecture, and sometimes you can and sometimes you can't. Right now I think that we're in a phase in our careers where we can't, the tools aren't quite there yet. So it's really important that you have a basic understanding of some of the operational principles so you know what you're replacing them with. It's like the old leaky abstraction problem. So in our case, we have a couple of different ways that we could host our application. We could use Heroku, okay? I don't want to say you can't use Heroku, but in our case, it's $2 more per month than the cheapest DigitalOcean instance, and if we were to use Heroku, the rest of my talk doesn't make any sense, so we're not going to do that. But you don't have to use DO. You can use pretty much any other virtual host provider, of which there's several. I mean, the big ones are DO and AWS. I guess Microsoft has an offering as well, but I haven't worked with it. And so when you're selecting a host, there are a number of different things you need to think about, what is your intention? And so in our case, we're doing a really simple personal project. And I think DigitalOcean is really excellent for that. So let's go ahead and start out by creating a virtual machine in DO. And the reason we're going to do this right now is because it takes a minute or two for the machine to spin up. So what I don't know is how to get this screen to show up for you all. Technical support, IT, Adrian, how do I make the thing go? Because that's a big cornerstone part of what we're doing is I want you guys to see what I'm doing. Oh. All right, well, let's talk more about what this thing does. Yeah, right. Remember these days? Yeah, awesome, great. Anytime you do a live demo, things aren't expected to work, so I'm kind of resigned to that fact. So with respect to different hosting providers, DO is really simple. They've got a really small feature set, but they're quite affordable. Amazon is a larger feature set, and so that's really interesting because I do use Amazon quite extensively, but for most of the jQuery work, we host almost all of our infrastructure on DO. And that's not to say that DO is better than AWS. There are a number of features that I would love to use that AWS has that DigitalOcean does not. But DO is very generous to open source projects and gives us a great deal of infrastructure for free. So I'm going to go where the free stuff lives. So features do matter when selecting a host. And the things I look for are scriptability, right? Is there an open API? Does a node client already exist? These are important things for me because I want to do stuff like automate as much of my infrastructure as possible. I want to write utility scripts and allow other people to do basic management stuff. And I also firmly believe in immutable infrastructure, meaning that I don't ever upgrade a server. I mean, I'll allow the server to apply patches on its own, but if I need to ship new software, I'm going to blow that thing away or I'm going to create another machine and then start pointing traffic at it. So you have, your current version and then your future version. Once that looks good, you keep moving forward. So scriptability, the ability to programmatically interact with your infrastructure is really important. And it's odd because every now and again I will run across a hosting solution that somebody's using, a customer of mine or an old open source project that I'm looking to migrate, and they just don't have. You got to like open a trouble ticket or call somebody to have a new virtual machine created or destroyed. It seems really wonky. Adrian, how do I show my other screens? And so any of these don't show up. It's only when I'm in presentation mode.
Oh,
how I do.
Because here is this. Oh. There we go.
Yay! You're so good at this.
Thank you.
Ladies and gentlemen, Adrian. Yeah, that's all it took, right? So yeah, did I say I'm a Linux administrator? Did I mention that? Someone gave me a Mac, and I feel like I'm lost. Okay. So let's go ahead and create a virtual machine. And I expect a lot of you have already done this. This is not the most interesting part. Also, I'm tethering to my phone because I don't trust the wireless here, so hopefully this will work out. Okay. I prefer Debian, just vanilla Debian. So like my system management stuff, I want everything as simple as possible all the time. I'm not a really fancy person. The fancier things get, the more complicated they get. In this case, I'm going to choose the San Francisco data center because it's just down the street. And latency matters today, right? So, okay, I'm going to call this thing Node Friends because you're all my Node friends. Thank you for coming. All right. So we chose DO just because we had to make a decision. AWS is interesting if you have scale envy, if you think that your application is just going to go super nuclear. AWS is a really neat option because there's a lot of other features that you have in that same package that you can just sort of enable and connect everything together. The downside about using an integrated solution like AWS is that if you ever look to move to another hosting provider, all those little components that you've added on through their web interface that are so easy to use, or you have to recreate each one of those on your way out the door. So that can be a little bit overwhelming. All right. So after you create your virtual machine in every hosting solution I've seen, you get a public IP address. And this is critical. If you don't have a public IP address, no one's going to be able to reach your server. So let's go ahead and just snag that for now. Okay. Oh man, that's such a bummer. So if you share the screen, yeah, all right. But so now we need to configure this virtual machine. So we have a virtual machine. There's nothing in it. We could SSH into it if we want to, but there's nothing there. So what's the point? Next thing we need to do. So now we have a virtual machine. That's great. Now we have a place that we can host our application. Next thing we need to do is obviously register a killer domain name, right? Like everyone needs to be able to access your site through a catchy domain name. So you need to register a domain name. I think we're all on board with that. All right, let's do this again. But before we do that, let's talk a little bit about DNS. I mean, I think we're all using it every day. Part of it is that nobody wants to memorize like IPv4 IP addresses, and nobody certainly wants to memorize IPv6 IP addresses. They're even longer and weirder, and just uncomfortable. And so that's too bad, right? So I wrote all these notes, and just throw them out the window. Okay. So DNS is pretty cool. Before DNS, so there was a time on the internet where we had the internet, but we didn't have DNS. And it was all IP addresses, and the only way, if you bought a new computer, if you were, let's say, at Cornell or something, and you got a grant, and you purchased a new computer, and you wanted to put it on the internet, there was one place you had to contact. You would get in contact with Stanford Research Institute, SRI, and they had a single file, and it was called host.txt. And in this text file, it contained every computer on the internet, every one of them, 100%. And so you had to get a hold of them, call them, or write them a letter. I don't know if they had email at this point, right? Because it's all very opaque to me. And then they would add your host name and add your IP address to the file. And then other computers on the internet would eventually download that file. And now, baby, you're on the internet. You're doing it. So at a certain point, around like 1984, people kind of figured out that this whole single file thing is just not adequate. And the internet was beginning to grow and take off. So they came up with this big global database, and that's what we have in place today. This is a huge, like replicated database. It's many levels. It's very fancy. At the end of the day, what we're getting out of it is host name to IP address mapping. So when you search for google.com, you're going to get one or more IP addresses, like phone numbers you can call the website at, the server at, and that's much better than having to memorize that list of IPs. And that also provides a little abstraction layers. You can do things like provide multiple IP addresses, and you can change those IP addresses on the fly. And so you'll see this used in CDNs, for instance, right? If you are trying to pull content and you're in New York, you're going to probably get a server closer to you than I am out here in Portland. It's going to try to find. And that's all done through magical DNS. Now, there are all kinds of different types of records in DNS that you can use too. But for what we do, most of the time, we need A records and CNAME records. And that's about it. We let the other infrastructure folks worry about like MX records for mail servers. Sometimes you'll use a text record, to verify that you own the domain, because only the administrator of the system should be able to add DNS records for you. So that's a nice, easy way to prove ownership if you enjoy DNS, which I do. So in order to register a domain name, you must go to a domain name registrar. And I think a lot of us are familiar with GoDaddy, right, or Namecheap, or whoever. But again, back in the early days, there was only one registrar, and that was Network Solutions. And so they were the only registrar for .coms, .nets, and .orgs until about 1997, when a company named PG Media filed an antitrust lawsuit against them. They were the ones holding all the keys to the internet at that time, the naming, and there was no way that other people could sell domain names, right? So the lawsuit didn't stick, and Network Solutions still exists, and they're, as far as I can tell, an upstanding company, and that's good. But it did really change the sort of the landscape of the business of registration, and so now there are over 900 registrars. And so that's good, and because of this expansion of registrars, we also have competition in the market, and competition drives the price down. So when I was buying domains when I got started and there was only Network Solutions, domains were like 50 or 75 bucks, which, that seemed like a lot of money back then. So today we're going to register a domain name for 88 cents. And I appreciate that very much. And so the registration piece is basically just, it's just who owns the domain. Because there are all these different components. Like when you register the domain, that just is saying Adam is responsible for, this website.com. But they don't actually do anything like, they don't host a website. A registrar doesn't host your website. And a registrar doesn't host the DNS records either. So like all they're doing is managing this registry, parts of this registry. But before we get too far down the beaten path there, I'd like to, send a shout out to our friend Networking. What's up, Networking? How you doing? Networking is like really important. None of this is possible without basic networking, right? You've got to be able to push bits across the internet. But networking is really complicated. There's a lot of different aspects to it that are way over my head. And I was Cisco certified, and I know like at least a little bit about what I don't know, and that's a good start. But in web dev and application development, the networking pieces we need are pretty slim. Most of the time, all we're really concerned about is like, what's the IP address that our application is running on, and what port is it listening to? And so we have two different types of ports. We have high ports, and we have low ports. It's like this classist struggle of the ports. And most of the time when we're doing local development, running as a regular user, a non-privileged user, we're going to configure our app to listen on like high ports, on port 3000 or port 8080 or 8888. You know, these are the common things that you see. But why? Why are we running on the high ports? Well, it's because the low ports 1 through 1023 are reserved, and they're reserved for the system. And this is this is like this old security model. So let's take SSH for instance. So SSH runs on port 22. So when you say SSH, you know, name at my host, all that traffic is over port 22. You make that connection on port 22. And so port 22 is a protected port, meaning that only the root user can start an SSH daemon and have it listen on port 22. And that's important. So imagine a world where anybody can start a node process that listens on port 22. If your SSH service dies and Joe Random spins up their own node process that does nothing but listen for your connection, you can never be sure when you connect to your computer if it's the SSH service that you started or the one that your user started, because anyone can bind to port 22. Now, it's not the greatest security model, but that's why it exists. They were trying to make networking secure. So enough about networking for now. Let's get back to DNS. So we still need a DNS host. So we talked about like Namecheap and GoDaddy. Google will register domains for you. Everyone's getting into the game. I think Amazon will allow you to do that too. So that's pretty neat. But let's go ahead and register a domain name through Namecheap. And this is where I need your help. We need a domain name, but I'm only willing to spend like $1.50, including fees. I'm sorry I'm so cheap. I am but a lowly open source programmer, folks. I'm sorry. Okay. So we're going to mirror the displays again. Yeah. All right. Does anybody have any killer domain names in their head? Something I can memorize easily. Node friends? Okay, let's do it. Is it available? So look, they've even got a tab for 88-cent domains. Fantastic. Nodefriends.club. You are all in the club today. Welcome. All right, let's go through this. This will be fun. I think the next talk I'm going to give, I'm just going to stand up here and do like regular work for 30 minutes and see if anyone notices. This is very similar to what I do for a living. We're not going to auto-renew. Sorry, this is an exclusive one-year-only club. Okay, and we're going to pay now. I'm going to pass a hat at the end. If you want to be part of the club, it's going to be 10 cents. Okay. So unfortunately, like, there are different delays in this process, and so my intention is that we'll run all the way through this tip to tail, and hopefully everything will work out. But there is a chance that because we're dealing with, remember that big old global database? Because we're dealing with that, there's a chance that it could take some time for some of these bits and bobs to move around. But hopefully we don't have to deal with that. Sweet. Okay, awesome. We've got ourselves a domain. I'm so excited. I've never had one before. This is my first one. And you guys are here. Okay. See, these are my notes. This is what I'm reading to you. Yeah. Let's see. All right, so we've chosen a DNS host, and we're gonna use Namecheap because that's what I use for my personal stuff. You know, I'm not shilling for anybody. This is what I use. There was like a big GoDaddy exodus some years ago, and I followed the popular crew and went along with it. So now that we've got our domain name registered, we need to start creating some DNS records, and those DNS records should point back to that DigitalOcean virtual machine that we created. And there's a couple of different ways to find a host for your DNS records. Oftentimes, so again, these are different services, right? You register the domain, and then you have to find somebody to host your DNS records, and you have to find somebody to host your web application. So we have our DNS host, and oftentimes the DNS hosts will also provide DNS record hosting for you. So you can host your DNS where you registered your domain. That's handy. But you can also host your records sometimes with your virtual host provider. And so that's what we're going to do. We're going to tell Namecheap that that DigitalOcean is the authoritative DNS server for our domain. So let's make that happen. And each provider is going to be a little bit different about how you do this. So, you might have to RTFM a little bit and find how things are set up. Okay. These are all the little domains. Here we go. Nodefriends.club. We're going to go to advanced. Oh, no, we don't want to do that. So we're not going to use Namecheap's DNS, so we don't have to go to advanced DNS. Our DNS is not advanced at all. So what we do down here is under name servers, instead of using Namecheap servers, we're going to use custom DNS servers. In our case, we're going to use DigitalOcean. Okay, you guys can see what I'm doing? Awesome. And then we hit save. And so this is where it gives us really scary warning. It says like it could take up to 48 hours for the information to propagate. Yeah, up to 48 hours to take effect. In my experience, it's been about 3 minutes. So that's a pretty good margin of error. Okay, so now we're over at destroy. We are over at DigitalOcean. So let's recap about where we are. So we registered our domain name, and oh man, we didn't want to do that. We're going to do this again. So now we're going to create. I've run through this a couple times. Can you tell? And we're going to create the virtual machine. And sometimes I like to name the host name of the virtual machine to match my domain if I know I'm not going to have more than one instance. So generally the way that you provide availability or higher availability is by having multiple instances of your application. So if you don't need that, you can have one name. You don't have to do something goofy. Different services will provide like globally unique IDs, and then you have to map those back to your application. Again, for a personal project, I think this is as tight as we're going to get. Okay. You're awesome. That's such a feel-good message. So now we've got our domain registered, and we've pointed our authoritative DNS over to DigitalOcean. We have deleted once and now recreated the virtual machine, so we know it's good. But since we've told DO that they're going to be responsible for the DNS, we should probably create the domain and the records that we need. So I wasn't aware that it did this. Let's see. But look at that. It does all the record setup for you. So we just hit create record, and it'll create the zone for us, and it'll create the stub records that we need. And this is awesome because in some services will create a whole bunch of records that you don't actually need, like CNAMEs for like things for mail and web panels, cPanels, and we don't need that. So what we have is just the IP address and then the list of the name servers who are responsible, the source of truth, so to speak. So now we're basically on the internet. We're published. We're ready to go. I don't know so DNS should be like actively replicating across the internet right now. Like it's just rushing to get these new records out there for us. And I'm really appreciative of that. So let's see if it works though. There we go. So this is a live DNS query. So if you all are interested and you use NSLOOKUP, you can see that nodefriends.club is being resolved to the IP address that we published in DNS. 211. That's a really good sign. Okay, so now to recap where we are. We have a domain registered. We have DNS hosting set up, and we can verify that DNS, that domain name will resolve to an IP address. And we have a virtual machine, but we're not really sure if it exists yet. So let's try to log in. Since it's the first time they've seen, we've been to the server, want to make sure it's good to go. All right, we're in. So whenever all right, so let's go back to my talk. All right, so that's why we're here, right? So this is great. Like we're actually, this is working better than I expected. So now we get to configure our server. Right, so we've got all the different pieces. We have the ability to pass traffic up to this server, but the server is an empty bucket. It's just default. I deleted it once by accident. So it's clean. It didn't swap anything out at the end. Whenever I'm setting up a new machine, the very first thing I do is patch it. Like you had a virtual machine created. I don't know where it was. I don't manage the image that was created. So let's get that thing current. Once you've got your app server patched and ready to go, you at least have some assurances that it's somewhat secure. And then after that, you want to install the software. And so there are a number of different ways on a Linux system to install software. And so I'll talk about those in a little bit. And after you've got all your software that's required for your application, like Node, you need Node, right? Now you can install your Node application. So this is so funny. I hate that you guys get to see this. So for me personally, there are a few different ways that you can build applications. You can build stuff from source. You can get clone the repo and read the documentation and go all the way through like a /configure make install. And it will take that source and it will compile it and it will generate a binary specific for your platform, if you're lucky. And most of the time it does. The downsides of compiling from source is that it takes some time. So if you're doing something like trying to compile a cat facial recognition application directly on the Raspberry Pi, it's going to take a very long time. It's not like a big multi-core processor like we have in our laptops. So that's a downside so that alone's a downside in building from source. But you do, if you build from source, have the ultimate control over what features are enabled or not at compile time. And it's pretty rare these days that we'll run into a situation where you have to compile something because the feature's not there. But it is an option. I don't use it very often. The next thing you can do is you can go out and, like, let's say in the case of Node, we can go out and download a precompiled binary of Node for whatever system that we want, right? For a Linux system or OS 10 or whatever. You just got to make sure that it matches your platform. And this is pretty cool too. This is better, but still not great. So you go out and you pull this binary down, you just put it in the right location, and it's there. The downside is that if I go this route, then it's up to me to stay ahead of the security fixes. I need to proactively monitor the websites or the channels where security information comes, because if there's a hole in that application, I'm not going to get an update. So the way that I really prefer to install software where impossible is using the package manager of my distribution. So again, I'm using Debian, and if I'm going to install Node, I want to use apt to do that install for me. Unfortunately, by default, the version of Node that ships with Debian is generally pretty old. I like to stay on the leading edge of Node. I don't care about LTS support for my own personal projects. And so in these instances, most package managers, and again, it's distro specific, but most package managers have a way that you can add external repositories so you can go get newer applications. And so in the case of Debian, you can add a PPA. And so it's basically another server that's hosting newer packages of Node for us. So let's do all of those things. Oh, also, here are the cheat codes. So everything I'm doing is right here. And so if anybody's interested, I can share the gist with you at the end. I mostly put this here so I don't have to type everything by hand. So let's go ahead and we've logged into the host. Whoop. You guys see that okay? No, not really. That better? That better? Is that better? That's better. Okay. So we're going to add the PPA for a newer version of Node. This is coming from our friends at NodeSource. Thank you, NodeSource. You're staying ahead of our packaging systems for our friends at Debian. So this will allow us to install a newer version of Node. So in this case, I'm installing Node version 6. And so now we've added our PPA. The next thing we want to do is patch the system to current. And this just takes a second. There's not much there. And so while that's running, we'll get our list of software to install. And the list of software to install is going to vary based on your personal application. In this case, we don't really have a lot that we're installing. And so my application is very simple. So we're installing Git so we can git clone the application from GitHub. We're installing nginx because I want to use that as part of my hosting solution. And we're also installing Node because that's what I wrote the script in. And without it, this whole presentation is going to be even more difficult to pull off. Okay. All right, so here we go. We've got a patch system. We've got a version of Node on here. Boop. Got a version of npm on here. Boop. That's good. So these are all the basic components. So we have a server that's configured the way it's configured to host an application. So now we need to get our application from somewhere and stick it on the server. So let's do that. And there's a couple little wonky things we're going to do here. And I'm sorry this has to happen. Just don't look at this part. Okay. So let's go ahead and clone our application. Yay! And let's go ahead and grant the www data user access to the application. So when you install nginx on Debian, it creates a user account called www data, and this is just a non-privileged user that we can use for running our web application. So at this, all right, let's go ahead and run this. So we're going to use that user to start our application up. And that's nice because our application won't be running as user root, it'll be running as user www data. So if I've got some security holes in my application and somebody tries to like execute shell commands or something through my app, it'll just be running as user www data. So there's not a lot it can do. Okay, awesome. So now we have a web server. We have our web server running. We have our app server is running. It's configured. Our Node app is bound to port 3000. Like all in all, we're in pretty good shape. So this is great. You know, if you open a browser now and you go to nodefriends.club:3000, it'll return data. But like my mom's not going to do that. And if I want to show my mom my work, which is important because she prints all the things that I do and puts it on the fridge still, which is amazing. She's not going to know about that port. So what we want to do is get to standard ports. And so our standard ports for our browsers are port 80 for insecure content and 443 for secure content. And again, those are low ports, right? So I can't just use my www data user to bind to them. So we're going to need some other application to do that. And what I prefer, oh man. Oh Blaine, I've missed so many steps in here. So what I prefer to use is nginx as a reverse proxy. And so what we've got here is the gruntjs.com configuration. The other thing that's really interesting is like this is a contrived example, right? Like I'm just hosting a garbage application, but the truth is the exact same steps that we're going through today this is the exact same hosting environment and setup that gruntjs.com uses. The only real difference here is that we've got Cloudflare sitting in front of the server to reduce the amount of traffic that the basic server receives. And there's other niceties on the server itself, but the concept is the same. Okay? So we've got our Node application running on port 3000, but we need traffic from ports 80 and 443 to reach our servers so our moms don't have to put :3000 in front of our URLs. And so nginx is a tool we use for that because nginx is a phenomenal web server. It does a lot of things for us already, and it has a lot of advantages. Some of the key advantages, in my opinion, is, well, I mean, it's really common and easy to get support for. Using it as a reverse proxy in this setup is really common, so you can get a lot of good support there. When it comes to SSL, so Node itself, like if you read the release notes, there's a lot of security churn and a lot of bugs around TLS, which is where that's the SSL component of Node. And so I don't want to deal with like SSL termination in my Node application. So I'm going to install my SSL certificates within nginx and let nginx do that hard work. Because I know that a lot more people are focused on security with nginx than they are with Node. So it allows me, and again, the operating system patches it very easily. I don't have to keep going and updating my Node version. So what we're going to do is we're going to configure nginx to route this traffic to our application. Let's see if we can do this. Okay. Okay. Is Node still running? Awesome. And what did we call this thing? Node Friends? Nodefriends.club. So we're going to just modify this. We're not using grunt.js, right? We're nodefriends.club. And we are running on port 3000. So in theory, that's all that needs to be done. So we're saying, hey, server, anything that's coming in on port 80, for nodefriends.club, go ahead and redirect it to our local process running on port 3000. I like the sounds of that. Ooh. And let's restart nginx. So okay, so at this point, we should have nginx working. DNS should be able to point our browsers to our nginx server. That server should in turn hand the connection off to our node application. And our node application should do something. So can everyone reach nodefriends.club? What's the page say? What? It totally works. Yeah. Awesome. Well, so I guess, that's kind of what I do, right? Like a lot of the open source work that I do, I mean, when we're hosting web applications, you're just trying to take code out of a repo, stick it on a server, and make sure that people can route their browser's traffic to it. It's not all that complicated, and there are a number of different ways that people can solve this problem, but this is how I solve these problems, at least most of the time for the jQuery Foundation and our supported projects. So these are all the things we've done. Fired it up. This guy's not sure how to profit on it, but he will. But it's not a complete solution by any stretch of the imagination. Did you remember that command line hackery I had done? Okay, so I just started that node process and left it alone. So if you all hit it at once, there's an excellent chance it's just going to fall over and it won't start back up. And you'll start to see like 502 gateway errors from nginx. And that's not good for a production environment, right? So the next thing you probably want is some form of process management. When a process dies, we should restart it. And that's also, like a node philosophy thing. Like you want to have multiple services running, multiple instances of your services running. In case one dies, there's just another one sitting right there. Load balancer takes care of all of that for you. We're not doing any of that. Right. Beyond that, configuration management would be excellent. All those steps I ran through by hand should be moved into an Ansible file, and then you can track the changes to your infrastructure as code. And for developers, that's a really nice thing to do, and it makes recreating this easily. Now, in our instance here, it took, 5 or so minutes to really type the commands in, but imagine doing that 30 times a day. It gets old. You can also introduce desktop virtualization to aid in your testing. So when you do have an Ansible script and you want to test it on what would be your production machine, don't just fire it against production. I mean, you can, but that's a really hardcore way to work. This application also needs SSL. Everyone wants SSL now, even if they don't have any secrets on there. And the easiest way to get there is to terminate SSL within nginx. Nginx is wonderful for that. You can also use Let's Encrypt, but as far as I know, there is still no built-in nginx module for taking care of renewing that certificate for you. We can also automate server creation. Because DigitalOcean has a nice API, we could have written a single script that goes out, creates the virtual machine, configures it the way that we want, pops in, clones that repo, starts the whole thing up, and leaves it alone. That's how I do it every day, but this is the longhand way. So this is not something you have to get to. You can work your way towards it and kind of whittle off the high spots over time. And to keep things running, I generally will use systemd. Again, I try to stay vanilla. I stay with what's in the system. That's not the only way to do things. PM2 in the node land is really awesome as well. And I would definitely recommend that you take a look at systemd if you're on Debian, or PM2 if you're on any other distro. I think I've hit the end of my time. So thank you all for hanging with me. I'm glad it didn't explode. And the website is yours. Welcome to the club.